Assalamualaikum warahmatullahi wabarakatuh, and a very good day I bid to the panels. My name is Fadhilah binti Tugiman, and my supervisor name is TS Dr. Nur Rashid bin Mat Nuri, Alliance Madin. So for my project, the title is Simulation of Longitudinal and Lateral Vehicle Motion in Double and Change Maneuver. Okay, so this is the presentation outline. I will go through the introduction first, where in this part it include about the background study, problem statement, research objective, and also the scope of the research. And then for the second part is about the literature review, where I will review the research from the previous research, and the test for the double and change from the previous research also will be reviewed in this part. And the third part is methodology, and the last one is results and conclusions. The first part is introduction. Okay, to introduce my thesis, I will share about the background first, where the project is focused about double and change maneuver. And this kind of maneuver is very popular because the driver always do overtake during driving. Even though this is the very basic maneuver, but it can also arise risk such as accident on the road. Okay, so in order to make safe double and change maneuver, the driver need to make a decision and prediction well during drive. Okay, next for the problem statement. For the first one is driver behavior and road conditions are the two causes that contribute to problem during lane change and maneuvers, which can result in road accident. And the second one is the accident on the road causes by the less efficiency of the vehicle, stability and handling during changing the movement of the vehicle. For the research objective, for the first one is to develop vehicle dynamics model follow the longitudinal and lateral vehicle motions in MATLAB Simulink. And the second one to investigate the vehicle performance in double and change maneuver. Okay, next for the scope of research, firstly develop the 14 degree of freedom model in MATLAB Simulink, and then set up the parameter such as the inertial longitudinal position of gate entrance in unit meter, and time in unit second, and longitudinal entrance velocity set point in unit meter per hour. And then use the 3D visualization to simulate the vehicle movement in double and change. Okay, next literature review part. So the first one is review about the double and change maneuver. Double and change maneuver is a situation where the drivers overtake a vehicle in front of their vehicle, and this is one of the risk, behavior and action during driving. And many researchers do the double and change test by referring the International Organization for Standardization, which is ISO standard. Okay, next for the double and change test on an asphalt road. The author do the double and change test to verify the efficiency of the road friction coefficient estimator and the tire cornering stiffness estimation. And the author also used the adaptive model predictive controller to track the desired path accurately in real time and to ensure stability and comfort. Okay, next for the double and change test vehicle to validate dynamic modeling with tire blowout or punctured tire. The changes in the tire characteristic parameters when the tire blowout are the direct cause of the vehicle motion. And the author found out that through the study, the FPID controller well performed than the PID controller in terms of performance, even when the vehicle speed in high and the degree of deviation correction is considerable with a quick response on vehicle stability control. Okay, last one, the double and change test to validate longitudinal and lateral controller. In this test, the longitudinal and lateral controller is tested by driving a double and change according to ISO 3888 Part 2. So in this study, the author testing on the driverless car, and they found that a defined path at high speed close to the vehicle's limit by altering the longitudinal speed by the accelerator or brakes and the vehicle's direction through the steering wheel. And now go to the methodology part. Okay, next for the project flowchart in the methodology. Firstly, listening the briefing of PSM1 by Mr. Low. For the next is identify the problem statement and then do the literature review. Next, development of the 14 degree of freedom model in the MATLAB Simulink. And next, determine the parameter and measurement required for the analysis. And next, testing the analysis. Next to result and discussion. And last one, report writing. Okay, so this is the double and change model that I use in order to test the double and change maneuver. Okay, so this is the parameter setting that I use for the double and change test. Okay, so for the first one is maneuver setting time, which is 25 seconds for all the 3 tests. And the parameter that I change only at the initial longitudinal position of gate entrance, which for the first one is with the 175 meter, and then 88 meter, and the last one 58 meter. And the other parameter like longitudinal entrance velocity set point units meter per hour still keep the same, which is with the 35 meter per hour. And the vehicle width keep same for all the three tests, which is 2 meter. Okay, for the next sem final year project 2, I will continue by changing the longitudinal entrance velocity set point value for all the 3 tests. And this is the preliminary results for the 3 time tests. For the first one, for initial longitudinal position of gate entrance in 175 meter, and next for the second one, for inertial longitudinal position of gate entrance 88 meter, and then for inertial longitudinal position of gate entrance 58 meter. And this is the 175 meter test result, where we can see that the vehicle starting to do the double and change in 17 seconds, and the 88 meter test result show that vehicle start to double and change maneuver in 12 seconds. And the last one, for the 58 meter test result, vehicle starting to do the double and change maneuver in 10 seconds. Okay, so this is the double and change test graph. So the purple line showed that a target trajectory, and the green line actual trajectory. For the blue line, it showed the right lane boundary, and for the red line indicates left lane boundary. To discuss about the preliminary result tests, as we can see that all the result tests show that it has the same pattern except for the velocity graph pattern. And for the 175 meter test, it has the longest time taken to do the double and change maneuver compared to the other test, which is 88 meter and 58 meter. And we can do the hypothesis where the inertial longitudinal position of gate entrance, the longest time taken for vehicle to make the double and change maneuver. For graph of double and change test, it shows the response from the actual trajectory target trajectory, the left lane and right lane boundary. The maneuver passed the double lane change test as it shows that the actual trajectory is in the range in the right lane and the left lane boundary. Overall, the simulation proved to show the longitudinal and lateral vehicle motion by double lane change test. Okay, to conclude, the double lane change test was done and presented in this thesis to validate longitudinal and lateral vehicle motion, and the research objective such as develop a vehicle dynamic model tracking longitudinal and lateral motion in MATLAB Simulink, and last, investigating vehicle performance in double lane change motion are all met. And overall, the double lane change test vehicle motion demonstrating longitudinal and lateral vehicle motion during double lane change test maneuver. That's all from me. Thank you.